Alright, welcome to our fifth video of atomic theory. This one we're finally showing how we go from the quantum mechanical model to electron configuration. So, with the quantum mechanical model, we finally have that electrons surround the nucleus in a cloud. As a reminder, nucleus and our cloud. That is basically the quantum mechanical model. Now, it goes into the different shells and subshells and orbitals, etc., but it basically says that we have a cloud of electrons as opposed to actual set paths. In 1919, Mr. Rutherford discovered that protons exist. And about 1932, James Chadwick identified that the neutron also exists. Now, we already had the electron, but now we have, finally, protons, neutrons, and electrons. So, now we know that the nucleus is consisted of protons and neutrons, and electrons are basically moving around outside the nucleus. The question, though, that we start becoming interested in is actually how the electrons move. Scientists had been using what are called spectral lines for a while. Lines showing the energy released by electrons to count ultimately how many electrons there are in atoms. Now, spectral lines, what I've understood, basically look like this. Now, they're a little differently spaced, but they're basically lines of when electrons release photons and change in levels, they'll release energy. And they're able to track pretty much how many lines there are and get an idea of how many electrons there are. We'll actually talk about this process in a little bit. Nowadays, we use this called photoelectron spectroscopy. It's kind of like the advanced brother of spectral lines. But the issue, in 1925, George Uhlenbeck and Samuel Gaudsmit proposed a solution to a problem at that time. See, a lot of people had lines like this, but basically when they zoomed in, they found this. They were like, wait a second, we thought those were one lines. They're two. What's going on? This is weird. And basically, Uhlenbeck and Gaudsmit proposed the idea of what's called electron spin. Basically, that electrons, spin. So they proposed that electrons have an intrinsic property, meaning just kind of built into themselves. The God programmed, and there you go. Called electron spin. That causes each electron to behave as if it were a tiny sphere spinning on its own axis. So you've got, an electron that basically spins, kind of as if it's on an axis. And a spinning charge, keep in mind that electrons are charges, ultimately produces actually a magnetic field. So you've got basically these spinning magnets. And opposite directions of spin produce oppositely directed magnetic fields. So if I spin this way, I'm going to get a different charge than if I spin this way. Now, going into that gets a little bit closer to physics, and we're not quite focusing on that. However, let me show you where this actually starts mattering. These two opposing magnetic fields ultimately is what makes the splitting of spectral lines into closely spaced pairs. So those pairs that they were counting really were two electrons, but they were both spinning in opposite directions. The issue you got to realize is that they were really close to each other. Now, that in itself is okay, because of, we're going to talk about actually the next video. Let me move on. In 1925, however, Wolfgang Pauli discovered his Pauli exclusion principle. This is kind of our starting place for electron configuration. And he stated that no orbital can hold more than two electrons, and that these electrons have to have opposite spins. Now, I've mentioned that phrase before, at least last year, and we never really cared about the spins. But Pauli basically says, alright, we can have electrons that spin. That's fine. However, we're only going to have two electrons in every orbital, and if there are two in there, they have to be spinning in opposite directions. Because if they're spinning in the same way, they're going to push each other away. They're going to repulse each other, and you're just not going to have two. So every orbital can have two, and those two have to be spinning in opposite directions. With the knowledge that orbitals ultimately have different energies, they've got different sizes, and now that we actually have Pauli exclusion principle, we're finally able to start considering the arrangement of electrons within their atoms. So we know there's a cloud, but we're going to start looking at actually how that cloud is arranged, if you will, or more so, how that cloud is configured. That finishes our kind of last little section of atomic theory, kind of bridging us to electron configuration. In the next few videos, we'll finally talk about electron configuration. Thanks for watching.